Hey everyone, so topic for this video is the Frugal Architect, this website that you were seeing. What is this word meaning frugal? First time I heard, I did not know the meaning of this one, so let's ask Google. Using only as much money as food as is necessary. So it's about cost effectiveness. We use whatever is needed. We are not spending unnecessarily anything. So next tagline says simple laws for building cost aware, sustainable and modern architectures. So right now the company I work for is entirely on AWS infrastructure, and sometimes I have seen there are unnecessary costs that can be improved. So wherever I see there is a article or anything about cost effectiveness, that attracts me, like why not go through and understand more and see how much can I apply for my use case. So recently, while going through one of the AWS reinvent keynote, I got to know about this article, the Frugal Architect. Frugal, not sure if I am pronouncing it correctly, but this is how it is, the Frugal Architect. There are 7 laws about this one. If we apply it in our use cases on daily to do while architecting for the applications and in our companies or whatever personal project we are working on, believe me, we can improve the cost very much. Because wherever we are using any of the cloud services, initially it seems like that cost is very less, why not use it? But in my opinion, if it is a single penny and it is not necessary, why use it? Because for a day, for a month, it might look like that it is a single dollar, single penny only. But if we see it that it is a recurring cost which is coming every month, every year, that will multiply actually. And it's not about that money only, so it's about the mindset, right? So what I am using, whether that is relevant or not. So throughout this video I'm going to walk through, I'm going to read out these 7 laws here. Okay, so this website, this article link is in the description box itself. You can go ahead and read that out yourself, but if you want to read it with me, most welcome. Let's go through that one. So before reading out this these 7 laws, let's see what are the common pitfalls, what are the common scenarios that occur when cost goes up unnecessarily. So I asked it from ChatGPT, and it has given me some generic reason, and it applies in our use cases, in our use case as well. So let's see that. Okay, so first reason, it is saying unoptimized resource provisioning. Example, an organization provisioning instances with higher computational power and more storage capacity than actually required. If instances are not right sized based on the application's needs, it can lead to unnecessary expenses. So how do I know that if it is a right sized or not? So let's say I have provisioned some resources with certain capacity. So after using for a month or so, monitor that CPU uses are there, storage usage, some metrics are there, monitor that. If you are using that resource up to that much, keep using that. Otherwise, think about reducing that, right? Why take that? Why keep that cost unnecessarily, right? So lack of auto scaling. Next point is lack of auto scaling. Failure to implement auto scaling for applications with variable workloads. Without auto scaling, organizational might provision a fixed number of resources to handle peak loads, resulting in underutilization during off peak periods and increased low costs. So I think auto scaling, if anyone using cloud, auto scaling they will be using it, because that's what the purpose of cloud. You pay for what you use. When the demand is high, it automatically scales up to that level. So but obviously we have to enable that auto scaling, so it's engineering mindset for that one. Okay, so that's what about it. So data transfer cost, transferring large volume of data between different regions or availability zones within a cloud provider's network can incur additional cost. Organizations not considering the geography of their users and data centers may inadvertently increase data transfer expenses. So let's say whatever application I am working on, the main user base is India, and I am replicating the data throughout the world. So, and nowhere else that data is going to be accessed. So why transfer the data there? Okay, it's not a point there, right? So inefficient, next point is about inefficient storage usage. Storing large amounts of rarely accessed data in high performance expensive storage solutions rather than using lower cost options designed for infrequent access. Inefficient storage strategy can lead to higher than necessary expenses. This is also an important factor. Overlooking reserved instances. Not taking advantage of reserved instances or saving plans, running on demand instances continuously can be more expensive than committing to reserved instances, which offer a significant cost saving over time. So, sixth point is inadequate monitoring and alerts. The example for this, failing to implement robust monitoring and alerting system to detect abnormal usage patterns or unexpected spike in resource consumption without timely alerts. Organization may not identify and address cost issues promptly. Unused resources. Leaving unused instances, storage, or other resources running without proper decommissioning, this can result from oversight or the lack of automated process for resource cleanup, leading to unnecessary cost. Next point is about non-optimized database usage. Using high-performance database instances for applications with low database requirements, selecting the wrong database type or not optimizing queries can lead to higher operational costs. Not leveraging cloud discounts, ignoring available discounts such as restricted capacity, spot instances, or volume discounts. Organizations that do not actively seek cost saving opportunities provided by cloud providers may miss out on potential savings. Inefficient network design. Designing a network architecture without considering data transfer costs or implementing suboptimal routing strategies. Poor network design can contribute to higher than expected expenses. To avoid such scenarios, it's crucial to regularly monitor and optimize cloud resources, leverage cost management tools provided by cloud providers, and implement best practices for cloud cost optimization. So these are the 10 points, common 10 points that can be the reason for the excessive cost, unnecessary excessive cost. So when we have covered these factors, that why I am incurring too much cloud cost, then comes these theorems, these laws that we can apply in our organization and we can save the cost very much. Okay, so let's go one by one these laws. So I'm just hitting first one. So make cost a non-functional requirement. So let's read this in summary first and we'll go in detail later on. First law says make cost a non-functional requirement. Second law says systems that last align cost to business. Third law is architecting is a series of trade-offs. Fourth law says unobserved systems lead to unknown cost. Law 5 says cost aware architectures implement cost controls. Law 6 says cost optimization is incremental. Law 7 says unchallenged success leads to assumptions. So now let's go a bit in detail with each one and see what it says. First law, make cost a non-functional requirement. A non-functional requirement specifies criteria that can be used to judge the operation of a system rather than specific feature or functions. Examples are accessibility, availability, scalability, security, portability, maintainability, and compliance. What often goes overlooked is the cost. Companies can fail because they don't consider cost at every stage of the business, from design to development to operation, or because they are not measuring it properly. The math is simple. If costs are higher than your revenue, your business is at risk. This is great line. If costs are higher than your revenue, your business is at risk. By considering cost implications early and continuously, systems can be designed to balance features, time to market, and efficiency. Development can focus on maintaining lean and efficient code, and operations can fine tune resource usage and spending to maximize profitability. This is great. So, move to the second law, which says systems that last align cost to business. The durability of a system depends on how well its costs are aligned to the business model. When designing and building systems, we must consider the revenue resources and profit levels. It's important to find the dimension you are going to make money over, then make sure the architecture follows the money. For example, in e-commerce, that dimension might be the number of orders. When orders go up, infrastructure and operation costs rise, and that's okay, because if your system is architected well, you can start to exploit economies of scale. What's important is that infrastructure costs have a measurable impact on the business. As builders, we need to think about revenue and use that knowledge to inform our choices, because growth at all costs leads to a trail of distraction. Because growth at all costs leads to a trail of destruction. This is great. Coming to third law, these laws are saying all that is needed. Third law says architecting is a series of trade-offs. In architecture, every decision comes with a trade-off. Cost, resilience, and performance are non-functional requirements that are often at tension with each other. As the saying goes, everything fails all the time. Being able to defend against failure means investing in resilience, but performance may pay the price. It's crucial to find the right balance between your technical and business needs, to find the sweet spot that aligns with your risk tolerance and budget. Remember, frugality is about maximizing value, not just minimizing spend. And to do that, you need to determine what you are willing to pay for, right? So, coming to the fourth law, unobserved system leads to unknown cost. Without careful observation and measurement, the true cost of operating a system remain invisible. Like a utility meter tucked away in a basement, lack of visibility enables wasteful habits. Making meters more visible can profoundly shift behaviors. Though observation requires investment, not implementing adequate monitoring is short-sighted. The adage warns, if you can't measure it, you can't manage it. So these taglines are great. If you can't measure it, you can't manage it. Tracking utilization, spending, errors, and more is crucial for cost management. When critical cost metrics are placed front and center before engineers and their business partners, more sustainable practices emerge organically. Ongoing inspection lets you spot excess spend and tune operations to trim expenses. The return on investment in observability typically far outweigh the expense. Most importantly, keeping cost in the forefront encourages sustainable practices. That's one. So cost dashboard or metrics should be forwarded to everyone, the department, in the engineering department, in the users, in the application operations. Everyone should know that how much company is paying for this one. Law fifth says cost aware architectures implement cost controls. The essence of frugal architecture is robust monitoring combined with the ability to optimize cost. Well designed systems allow you to take action on opportunities for improvement. For this to work, decompose applications into tunable building blocks. A common approach is tiering components by criticality. Tier 1 components are essential, optimized regardless of cost. Tier 2 components are important but can be temporarily scaled down without major impact. Tier 3 components are nice to have. Make them low cost and easily controlled. Defining tiers enables trade-offs between cost and other requirements. Granular control over components optimizes both cost and experience. Infrastructure, languages, databases should all be tunable. Architect and build systems with revenue and profit in mind. Cost optimization must be measurable and tied to business impact. Moving to the sixth law, cost optimization is incremental. The pursuit of cost efficiency is an ongoing journey. Even after deployment, we must revisit system to incrementally improve optimization. The key is continually questioning and diving deeper. Programming languages provide profiling tools to analyze code performance, and while these require setup and expertise, they enable granular analysis that can lead to changes that save milliseconds. What may seem small optimization accumulate into large savings at scale. In operations, most time is spent running existing systems. There are opportunities to profile resource usage and identify waste reduction. At Amazon, we continuously monitor services in production to understand patterns and trim inefficiencies. Frugality takes persistence. By incrementally reducing latencies and infrastructure cost, we can optimize the cost to serve. There is always room for improvement if we keep looking. The savings we reap today fund innovation for tomorrow. The savings we reap today fund innovation for tomorrow. So this is great. So every line it says, it all makes sense, and we all should read this out again and again. Maybe put this article in calendar and revisit with your team at least once in a month or once in 2 months, so everyone is aware of this one. So final law says unchallenged success leads to assumptions. When software teams achieve significant success without facing major failures or roadblocks, complacency can set in. There is a dangerous tendency to become overconfident in the methods, tools, and practices that led to those wins. Software software teams often fall into the trap of assuming their current technologies, architectures, or languages will always be the best choice simply because they have worked in the past. This can create a false sense of security that discourages questioning the status quo or exploring new options which could be more efficient, cost effective, or scalable. You see this frequently when it comes to programming languages. "We are Java shop" is a phrase I have heard too often, and it can stifle innovation. Unchallenged success breeds complacency through assumptions. We must always look for ways to question, optimize, and improve. As Grasshopper famously stated, one of the most dangerous phrase in English language is "we have always done it this way." This is the most critical, most important line. I have read it again and again. We have always done it this way. Maybe I'm going to take a printout of this one and paste it somewhere in the wall. We have always done it this way. So that's all about this video. I hope you are going to revisit it and you found this information useful. So if you found this useful, don't forget to hit the subscribe button and share this with your friends. I'll see you in the next video with some other topic. Till then, take care. Bye bye.